Okay, so anyway, let us get started. So I believe everyone has the dataset that I shared in the previous class. If you do not have it, you can go over to Stack Overflow and download it, or you can find it within the WhatsApp group. It is just the survey data for Stack Overflow, and I just love it because it is real life data, and we don't want to use data that is unrelatable. So let us open our data sets, and I think this was the data set. Sorry, this was the notebook that we used in the previous class, and we introduced Pandas, and we said that Pandas has two basically data structures, that is a data frame and a series. Okay, we said a data frame, it is basically rows, columns, and a series is a list. And if you're looking at a data frame, for example, a series would be a list of whatever is contained in a row. And starting from where we began, we said that someone is saying that I still failed to copy it into my notebook. So for those who are having such issues, because if I open my folder right here, and then I come to get these, you see that for those on Windows 11, I think it's a bit easier. You'll find copy as path already done for you. But if you do not have something like that, if you're using an older operating system, all you do is just come into this path, this bar that shows the address bar, and just click in this empty space. And when you come to that empty space, you're going to have that bar set, have that address for you. But you'll notice that this address bar does not have for the file name, which is like survey results public. Okay, so when you come and copy this path, okay, just copy that path, and then you can Control C for me to copy it. And when you take it the other side, when you're trying to read it, like for example, where did we try to read our data from? We try to read it from here. When you come to paste it, okay, make sure that you include a slash and get the file name, okay, which is for example, in this case, this is survey results public, and it's a CSV file. Okay, it is a CSV file because when you check for the properties, you're going to see that it is a CSV file, comma separated values, and you need to get that name and also paste it there. That is if you do not have the copy as path option. Okay, so but the rest should be okay. So to rerun everything in our cell, you can come to run, because whenever you have a very huge notebook, you have 700 cells, you're not going to come and run every cell independently. So just come to run, and we want you to run all cells. Okay, run all cells to make sure that we do not have any error, and then we let it run. Okay, so we are good. So now we say that data frames are basically, they come from the key value pairs. Okay, so key value pairs, we said key value pairs are dictionaries, and we saw that in our Python, and we can get this key value pair and pass it into a data frame constructor to create a data frame. But we said that this is not the way you will be writing your data frames all the time, because you are having data that has been collected from 5 million participants. You have to analyze that data. You're not going to come and create key value pairs for each of the different entries. But point to note here is that this is basically the structure, and the column name is the key, and then the values under that column are what are composed in a list. Okay, so when we come to print it out, of course, we see that it is a table with rows and columns, and this is what we call a data frame in Pandas. And we saw that we can actually access different columns within the data frame. For example, here I want to access the first email, the first name and the email address. We just basically address it like this. But if it is just a single item, you do not need to use double these. You do not need to pass in a list in here. You can just basically do it like, for example, like this, if you want to only access the first name. But if you need more than one, return more than one column, you just need to pass in a list of those columns that you want to pass in. And we say that we have the count method, the count attribute, and this count attribute is, excuse me. So now we looked at a series, also very beautiful series. It's basically a list of these different, if we try to, for example, pass in a series constructor, we have it passed in like so, like how you see it. But in essence, it is just basically, if it is in a data frame, a series object is basically returned from the items that are within column. Okay, and we saw that here that we created a series. We gave it a name called names. Okay, I gave it a name called names. When we printed out the names, we received a series object. Okay, of course we can see the data type is an object. Okay, and when you check out the type of names, it is basically tells you that this is a pandas.core.series .series. Okay, so we continued, looked at different how to create data frames. Of course, data frame, this is data frame constructor. So we created data frame and saw how we could change indexes of a data frame, and we are going to see actually why indexes, creating these indexes is very important when we are dealing with pandas. Okay, and so let us we continued a little bit and then loaded our data set within, this is our data set, survey results public.csv. It's the one that we loaded, and it's the one that we are going to be basically dealing with. If you don't have it, it's on the WhatsApp group. So now also had the schema. The schema is basically, it was the schema showing us what kinds of questions that we are basically dealing with according to this data. Okay, so what kind of questions that this data is basically answering, and I shared both files within at the start of the previous class. Okay, and of course when we check the type of what we loaded here, it is tells us that it is a data frame. And now we started talking about things like exploring our data, and that is where we basically were at that moment. Let me make this a markdown, and markdown, I don't want a space there. Exploring our data, and I want it as a markdown. Create a space there. I want to make it a very big heading. And we say that when you want to describe the data, basically you want to look, no, this is not describing the data. You're just trying to find the rows, how many rows, and how many columns. Okay, you're just returning the shape of your data frame. You're trying to look at how many rows and columns that your data frame has. We saw that we can use the df.shape, and this df.shape attribute returns a tuple. Okay, it returns a tuple. These are the rows and these are the columns. So we can see that we do have 114 columns, and we have 65437 rows. And we saw that we can actually look at the df.head. Now, df.head is basically we are looking at this, we're trying to return the first rows of a data frame, and the first rows of a data frame are passed in here. Okay, so we're returning the first n rows that are within the data frame. So if we put 2, we shall return to data frame. We shall return to rows. If we put in 4, we shall return the first 4 rows. Okay, and we can see that when we print out our data frame. Okay, so we also saw the df.tail. Don't forget that this df stands for the data frame that we described when we imported this here. Okay, we could give it the name got and it will still work. Okay, if we say that this is got, it would still work, but because we want to be as descriptive as possible, we retain the df. In most cases, you have more than one data frames, you give them names like df1, df2, and df3, as long as you keep remembering which data frame carries which data, but you need to be as descriptive as possible when dealing with variable names. So don't be confused by where the df comes from. So if our data frame, we had called it got, it would now be here something like got.shape. Okay, and it will still return everything perfectly. So but now here we since we named it df, let's continue and say df. So df.tail returns basically the last n rows that you want. So if you say I want the last 4 rows, you're gonna get the last 4 rows. If you say I want df.tail 5 rows, you're gonna get 5 rows. Okay, but these are going to be the last, okay, at the tail of your data frame. And so we saw that we can actually try to access different columns, and by accessing different columns, we can use we can just use this list. Okay, so you can basically try to use these square brackets. So df, and then open those square brackets and then pass in the column name. So now the column names, of course, are right here. You can access any column that you do want to access, okay, by just passing it. So we can, for example, get employment. Let me copy that and say df. Let me just create something below here and say df dot, sorry. So we're trying to access employment. Okay, so if we say df with employment, it's going to return whatever is within that that employment column. Okay, and see employed full time, but of course the data is truncated here. Okay, because you cannot display all the 65,000 rows here. You will scroll and get tired, so it truncates it in most cases. But we will see if we want to access the full data, how do we do it? So we saw that we can also use the dtypes attribute to check for the data types of whatever is within our data frame. Response ID has an int 64, which we said is an integer. Main branch has object. We said object, this refers to strings. We have float 64, which is of course a float, and the rest. Okay, so, and we can actually try to filter out our data and say if we want to access more than one column, how do we do it? Of course, you will use the same notation here, but if you're returning more than one column, okay, if you want to return data from more than one column, you need to pass in a list. Okay, but I say that if it is one, you do not need you don't need this list inside here. You can just pass in the column name without passing in a whole list. Okay, and so we also saw that we can access rows. Okay, all along we've been trying to access these columns, okay, these columns, but here we can see that we can access rows, and we looked at the loc and the iloc, okay? So let me just give it a name, accessing rows. So when you are trying to access these rows, you pass in, we have the row, the loc and the iloc, and they said iloc stands for integer location, okay? So we're basically trying to access the row by its integer, okay? So if, for example, our data frame here, we have integers 0, 1, 2, 3, 4, 5 up to the last number of the row. So you can access everything by giving it an integer. You can access what is that integer 789, and you still get that data there. So integer location is basically passing in the integer location, but we say that loc is basically taking in the integer plus the column name, okay? So, and when you try to pass in integer, for example, we said loc at integer number 2, and we want the column of age. So you are basically going to return whatever is at row number 2, but the column of age, which says 45 to 54 years old. So, and then we also tried to, of course, play around with the loc and said df.loc, and we want integer 2, 3, 4, 5, 5, and we're checking for the education level, and we see someone who has BA, BS, the Bachelor of Engineering, something like that. And I think that is where we are. And most of you, that is where we are stopped. That is where your code should be stopping at the moment. Okay. So now let us try to continue a little bit about how to describe our data. Okay. So we have data. We have, for example, we can try to check for the information that is basically in our data. So, for example, if I said df.info, it is just going to basically give me a summary of the data frame, including the index, going to the range, the range of the indexes. It's going to give me the data types of the columns, okay, and also maybe the non-null values. So if you try to look here, we have class. What is it? It is a data frame, first of all, okay. By using the info method, you can get all this information. Range index, it is telling us that these are 65, 407 entries. Yes, sir.
I'm getting an error. DF is not defined.
If you had run everything, come to run and say run all cells, so that your cells are rerun. Okay. When you close, go to run and then click run all cells. First run all cells, because so that your Jupyter remembers the information that it recommits everything to memory. Okay. So first go to run and run all cells, so that your runtime is basically restored. Okay. So because if you do not, it's going to give you such errors. Has it run?
I have run all cells. Let me just test and see.
So,
but yeah, also, sure. Thank you.
Yes. Yes. So if any one of you also faces the same problem, just try to rerun all cells, say run and run all cells, so that everything is reset. So now, yeah, we were here. We said df.info is basically going to give us this range index. Is going to tell us that we have 65,437 entries, and okay, so that is the range from 0 to that. Okay, so we say that of course the range ends with a -1. So if we have 65437 entries, the range is going to run from 0 to 65436. Okay, so it's not going to be a 7 here. Okay, so columns, we have 114 entries. Okay, and we have the data types. We have 13 float 64. We have integer 64.1, and we have object 100. We said object stands for strings. These are integers, and these are floats. And what's the memory usage? 56.9 MBs. And that is basically the summary of the data frame. Okay. And we do have, of course, other methods like describe. So, but if you run something like df.describe, this is a method, so it needs those parentheses. If you run it, it's going to give you a table. Okay, it's going to return a data frame. Now, but this table is just basically descriptive statistics for the numeric columns. Okay, so we see, for example, it gives us these different things: count, mean, standard deviation. Okay, we have the mean here. We have the 25%, 50%. So what basically these are, and we are going to look at these more on Wednesday. I'm bringing a guest instructor to take us through statistics for most of us who have forgotten. So the count here is just going to be return the number of non-null values. Non-null values, I mean the non-missing values of each column. So we can see response ID has 64347 non-null values. We have these are all columns. Okay, these are all columns within our data frame. If you try to go and look at it, so we have these this is basically the non-null or the non-missing values of each column. Okay, we have the mean. Okay, so the mean is basically the arithmetic mean of all the values that are in that are in a column. Okay, so the mean is just basically the average of like how we remember it from our statistics. And then STD means standard deviation. Of course, standard deviation is just basically a measure of how spread out the values are from the mean. Okay, so from the average, how much how spread out the values are from the mean is basically our standard deviation, abbreviated as STD. So mean is just basically the smallest value in the column. Okay, so we have mean out here. This is the smallest value in the column, and then we also have the max up here, which is the largest value within the column. So, and 25%, these are basically the first quartile. Okay, means that 25% of the data basically lies below this value, and 50% of the data, which is the Q2, which is the median. Okay, so 50% of the data lies below this value, and also the 75%, which is the third quartile, shows that 75% of the data lies below this value. So they're just trying to basically return the descriptive statistics of your data frame. Okay, and this only works for the numeric columns. Yeah, you're not going to find these in a column like for example, maybe hobbyist, where they are going to tell you, sorry, I think which column was it? Let's try to go back to our columns, maybe like a column like employment. Okay, so now we have things like employment. You're not going to find data. You're not going to find an average, unless if you set some labels and say, like, maybe 1 is going to be for employed, 2 is going to be for student, stuff like that. But if you don't do that, you are going to basically have your data, this describe returning only the numeric columns. So we looked at the shape attribute. Of course, the shape just returns a tuple that represents the dimensionality, the rows and the columns, the data frame, and we also have actually a what is it called? It's an attribute called columns. So I can say df dot columns. Okay. So of course, df dot columns is just going to return, of course, the column names of the data frame. So for the column labels of the data frame will be returned if you run that kind of attribute. Okay. So now I want us to first go back to the loc and the iloc. When you try to use the loc, for example, the loc method, okay? So when you try to call the loc, it is, let me try to show you that if we say, for example, df, of course, we saw this df.loc, and we try to access maybe, oh, sorry, not this. So we try to access something like maybe at 23, okay? You're still going to get the same thing even when you try to say maybe this df dot iloc. Okay, so if you try to run these two, you're going to get the same data, of course. And of course, this is not by mistake. Okay, it's not by mistake, but remember that iloc will only work for an integer, but loc you basically work for a location. But now I want you to see that if we try to if we want to check for maybe multiple what are they, multiple columns within your data set, you can basically also still use the location integer. Okay, you can still basically look the location integer, and which you cannot do with basically the iloc. So still on trying to what is it called? Where are we? We are in trying to explore our dataset. One of the most important things is to try and check for missing values. So of course, missing values, you'll not get a dataset and miss out on missing values. All these datasets are always going to have missing values, and how you deal with them is very important. But first, you need to find them. So how do you find them? So it is basically we have say missing values. Let me get it on markdown. Missing values, run that. So we have a method called is null. Okay. So for example, if I say df dot is null, okay, df dot is null, and we run that, we are going to get it's going to return basically a data frame. But if you try to look here, we have false, 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 true, 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 false, false, false. So where there is the word true, that is where we have a missing. That's where we have a missing value. True, false. We have a missing value there. We do have a missing value wherever you see the word true. Okay, there's a missing value. And when we get to the point of handling these missing values, we are going to see how basically do we try to return only those, or how do we replace these missing values with whatever we want to replace them with, because you're not going to work with missing values. Okay, so still trying to explore, we can look at now. I want you to if we try to print out df, maybe let's return again our dot head and say maybe for columns. So we see that we have 114 columns, and of course, how do I know? It is written down there, 114 columns. But when you try to look at this, these are not 114 columns, okay? These are not 114. These are not 114 columns. These are just a few columns, and that is because Pandas will try to truncate your columns, okay? It will try to truncate your columns, but we can override that. We can override that setting by saying something like PD, which stands for Pandas, and we say set option, okay, set option, and we get a display attribute, display, okay, and we say dot, oh, sorry, display is still within the same quotes, dot maybe max columns, okay, and we give them a number which is 114. So we run that and we get back our data frame. If we try to run it again, df.head up here, and we print it down, we are basically going now to get all the columns, all the column names printed out on our data frame, okay? So here we have the whole overview of all the all the columns of our data frame, and we can also do the same thing with rows. But of course, in most cases, it is not very important to read this data. You just want to basically analyze it, know what it is all about. Because if it is 5 million rows and 5 million columns, you're not going to try and view all that information. All you need is to get the insights out of that data, and that is how basically you try and run these cells. Okay, sorry, that is how you try to reset that option of so that Pandas does not, I think it's Jupyter that does it, so that it does not truncate your columns the way, so that you can see everything. So I want us to look at basically setting custom indexes. Okay, so of course, we can set custom indexes. Now you see that when we have something like, when you print out our data frame, we can see indexes from 0, 1, 2, 3, okay? So from 0, 1, 2, 3, these are our indexes. Basically, this is what the indexes that that Jupyter is Pandas so is assigning to our rows, okay? But in most cases, you find that you need to assign independent indexes. And sorry, you want to assign custom indexes. And this is how you do it. So for example, maybe let us try to read. We saw that we have a schema. How did we call it when we loaded it in our data frame? DF schema, okay? It is this one, okay? So let me try to load that data frame here. So DF schema, yeah, we can see it there. So this is basically the schema of our data. It is showing us QID, it has the Q name, it has question, the force RSP, I don't know what all those are, but all we need is to get what the column, these are our columns, and this is basically the question. Yes, sir. Hello. Okay, I think it was an error. So we are saying that these are our columns here, and these are our questions, okay, for which the people are answering. So for example, we have age, and the question is, what is your age? We have things like employment, and we have which of the following best describes your, but of course we see that they are cut, and we're going to see how do we basically view the whole question. So DF schema, let us try to say maybe we want to set now the Q name to become the index, for example. Okay, so we're going to say something like df schema. Okay. Df schema. So of course, don't forget your data frame name, which is df schema, and then we have another method which is called set index. Okay, so set index, of course, it's a method. It needs those brackets, so we can say that we want the index to be. Do we have a question?
Anthony should mute his mic.
I think Anthony, you have let me mute him. So now we have set index, and what does set index do? It takes in the what we want our index to be. In this case, we want it to be Q name. Okay, so which is that name that we have been seeing on the different columns, main branch, age, employment. We see them here, main branch, age, employment, and so we want it to be our index, and we want to add another this in place, which is true. So when we say in place is equal to true and we run it, okay, if we print out df schema here and we print it out, we are going to see that now the Q name has basically changed. Okay, it has basically changed, and we no longer have those numbers that we had there, the 0, 1, 2, 3. But when if you try to use things like log, okay, and put an integer, it is, let's see, oh, it is going to be schema df schema dot log. Okay, so if we try to print out something like this, it's going to bring a key error, of course. Okay, because we no longer have that kind. But if we say df ilog, of course, trying to locate the integer, it's going to bring in it's going to give us a very beautiful result, because the integer is still there, though we are not seeing it. Okay, we are not seeing the integer, but we are still we are basically still, this is main branch is still 0, this is still 1, this is still 2, this is still 3. Okay, until the end. So with ilog, you can still try to access most of these. But now, if you had tried to maybe reset these indexes,
Josh,
yes,
Josh,
yes.
Let me see how you changed the Q name. Sorry for taking you back.
It's okay. So when we have things like we want to set the index as Q name, okay, we just come and use the set index method, and the set index method, we shall use this. It takes in 2 arguments. So we have the Q name here, and the in place is true. So in place is true permanently saves our data frame in this structure, with the Q name being in the index column. Okay, so I think it is you have you understood?
Yeah.
Okay.
So you're trying to say that the Q name should be in that first place, right?
Exactly, yes. So, and we can also do it for for example, this data set. I just didn't want to mess with it, but I can set the index to be age, for example. Okay, I can set the index to be coding activities. For example, find hobbies, people who are coding as hobbyists, and people who are coding as maybe as a C hobby, but they contribute to open source projects and others. So you can set anything that you want as basically as an index. Okay. So now, but if you had reset it, if you had done it in error, maybe because errors happen. But if you had done it in error, you can try to reset it by basically using the df dot reset. We have the reset index. Okay. We have the reset index, but always don't forget the in place is to be equal to true, because you want this to be basically to take effect. Okay. And if you return the df schema, for example, df schema, it will oh, did it run? Reset index, and then return the df schema, run this cell, and then run this. Why doesn't it? Oh, no, sorry. It is df schema. Okay, df schema here. And when you run df schema again, we are going to get it going back to the default as it basically was. And we can actually try to even sort these things within alphabetical order if you want to basically view them properly. Okay, so for example, let me assume I had not done it in error, and I want my df schema to basically continue with for example, the queue name as the index column. Okay, so just rerun that cell, and Jupyter will save it to your runtime, and it will be like that forever. So you can use things like an FDF schema like dot sort. Okay, we can have the schema like dot sort index, which is also another method. Okay, and when you try to look at it, we have things like everything that has been sorted within alphabetical order. Okay, so exploring our data, that is basically a little bit about how we explore our data. Of course, there is more. There is more to that, but with this Pandas series, I wanted us to not. I don't want to have those long sessions. I want us to keep them short and sweet, because there's a lot to unpack, and with a lot to unpack, I want us to ensure that we are together all the way. So I see it is threatening to rain, and I want to run home. So let me cut my session here. Let me cut it short. I wanted to end at 9, but I see it is starting to drizzle. So on Wednesday, prepare to go through statistics. We shall go through statistics, a refresher for most of us. Look at some of the statistics that we are dealing with, especially when we are talking about this data analysis. How do you look for outliers? How do you look for, lots of stuff? So I'll bring a guest. She has already confirmed that she will take us through. And then on Friday, and I think we should on Friday we shall have a 2-hour session. Yeah, it will be a 2-hour session. I want us to go through different things, and then in the next week we shall start a little bit with NumPy, which will take basically one lesson or two, and then we start Matplotlib and Seaborn. So we shall spend just like one class or so, because drawing graphs is not that complex. The challenge is at interpreting them, and then we shall officially welcome Scikit-learn, so that we start now machine learning. But here, when you trying to analyze and find insights within data, it is not that very complex. So I don't know if I do have questions before I run. Do I have any questions?
Doctor, could we see that their code for sort index again?
This
Yeah.
sort index is basically trying to sort the index within this. But if you want to take it back, if you maybe say that I do not want it in alphabetical order, you can say things like df schema and say has to be dot sort index, of course, dot index, and in here passing something like ascending is equal to false. Okay. And when you do that, you are going to get them from in a reverse order. So there is a lot of methods, lots of attributes, lots of stuff in Pandas. Okay, lots of stuff in Pandas that if we decided to do a course on Pandas alone, would spend at least 3 months. But what is necessary for you to get started is what I'll take you through. So, but you will keep advancing the more you deal with Pandas. So yes, that is where we are at the moment, and I will see you in the next class. So I'm doing my my master's thesis around machine learning and non-communicable diseases. So if any one of you basically, of course, has data, working in an organization that has this kind of data about non-communicable diseases, I think it would be nice if you reached out to me, and because you want me to pass my master's, don't you? So let us, if you're working in an environment which supports that kind of area, please hit me up, because after launching the model, I'll need to collect data to train it. So, but thank you for listening to me, and thank you for being available today. We meet on Wednesday. Thank you.
All right. Thank you so much, Joshua.
Okay.